Naturally, of course. First thing I do is drop the thing. Good gosh. Got the way at the back. Whoa, good morning. All right, there's Holly. Check. There's Sarah. And Lee. And some more coming on. Good morning, Riley. Whoa, let's change that so you can see it a little bit more. I'll move it again once everybody gets here. And Marla, good morning. We'll give everybody a couple more minutes and we'll start up for the morning. There's Isabella and Priya. Super. And Dominic. Very good. So I got 9 of you. That's cool. Or 8. Let's double that and then we can start up. So we'll get a few more. Good. There's Magdalena and Tadashi. Super. And Lena. Okay, almost half of you. Let's give 1 or 2 more people a chance to come in and then we'll begin. Well, let me tell you what we're doing today. We're doing 2 things. We're talking about a last effect with waves called the Doppler effect, which you might know about or have heard of already. And then we're going to talk a little bit about the MSA and answer questions about the MSA later in the period. Anybody else out there? Well, if you know somebody, text them, wake them up. Okay, let's go ahead and begin. So, what is the Doppler effect, or when have you noticed it? Can anybody answer that? What's the Doppler effect, or when do you notice it? You hear it pretty often. Super, exactly. Yeah. Magdalena has it. When a police car or an emergency rescue car goes by, you hear a change in its pitch, a change in its velocity. And that change is real. So you've all heard it, it's this sort of Dun, 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 dun. It goes down, right, as the police car goes by. Well, that's not an accident. First, I want to write what the Doppler effect is, and then we're going to draw a little picture to help us understand why that is. Okay? Here we go. So it's a Doppler effect. It is indeed a change in pitch, or we're going to say a change in frequency. And can I have this thing sit a little easier? Change in frequency due to uh, the motion of the source or the observer. So it turns out if you're moving, it also matters. Okay? If you're just standing still listening to the siren go by, okay. But if you're moving, it also affects things. We're going to find out real quick here. And there's Shilpa. So good morning to Shilpa as well. There we go. Okay, so to do this, let's think of a train. Okay, so here's your basic ICE, and it's going this way. There's the track. Okay, the train's going really fast this way. And there's the train engineer. Okay, so there's the man or woman driving the thing. Okay, and let's draw a couple other people. Let's say we got a person out in front of the tracks, not on the tracks, but next to the tracks, out here waiting. And let's say we got a person back here where the train has gone by mostly, waiting back here. Okay. Anybody else out there? No. Small crew today. Disturbing, but 8 o'clock. If you know anybody else, tell them to get up and get here. Give them a text. Okay, so what happens? Let's say the train is honking its horn, essentially, right? Making its siren go. So as the waves head out next to the train, we're going to just draw the compressions, okay, and like circles coming out. So next to the train, here are the waves. Okay, and I'll draw them up this way too. So okay. But here's what's cool. As the train is going this way, let's see if somebody can answer. What's going to happen to the wavelength when I draw the waves out here? What will happen to the length of the wave because the train's going this way? See if somebody can guess before we draw them in. What will happen to the length of the wave? Here the length is from what? Compression to compression, okay? So there's the length. They will become shorter. Right on. Okay, Magdalena. So here we go. Let's try and draw that. So what happens is, because of the motion of the train, the waves get shorter. Isn't that weird? So when they get to this person out here, this person says, oh, well, if it's a shorter wavelength, then they're going to hit more or less frequent, everybody. If it's a shorter wavelength, they'll hit this person in green more or less frequently. So try and type something in. Tom is here. Thank you, Tom. Will this person hear the waves more or less frequently? Good. Okay. Yes, exactly. More. Shilpa has it. So, so a more frequent means it's a higher sound, a higher pitch. So this person says, oh, a high frequency is hitting me. That's kind of crappy. Why don't we say the sound is a high frequency. End of quotation. And this person, she's the engineer, and she just says, hey, you know what? It's normal. For her, there's no Doppler effect because she's riding right with the source of the sound, right? Well, the opposite's going to happen for the person in red back here, right? So the waves here, if they're bunched up here, they're spread out more. So they're further apart. So what happens is I get this effect. And I'm overemphasizing this, but you get the point. So that out here, she's saying no. It's a lower frequency, right? The compressions are hitting her less frequently. So who's right? Everybody. You'll find out if you study Einstein someday the same thing, that more than one truth can be in the picture because the circumstances are a little bit different for each one. Okay? But that's the Doppler effect. Turns out if person in green was running towards the train at a fast speed or driving towards the train, it would be even higher because she'd hit even more compressions if she was going this way. So the speed of the observer also matters. Yeah, exactly. Both are right, or all three opinions are right. The original is just the original. This person, she's driving the train. She's with the sound. So for her, it sounds normal. Past it, the waves are all spread out. They're hitting less frequently. So it's a lower frequency that is heard. And you know that's all three are true because you've heard all three. Right, fast car goes by. High, normal, low. High, normal, low as the car goes by you. Right? Kind of cool, huh? All right. So anybody else out there? Okay, where did I put my Tom? There he is. Well, there's there's an equation for this, and it's about the last equation we're going to learn how to use this year. So here we go. I'm going to give it to you, and then we're going to do an example together. And anything, yeah, Magdalena, do the waves here travel in ellipses? Yes, they do. Although it's probably not an ellipse that's, how should I say this? It's probably not a symmetric ellipse. It would be probably, Magdalena, asymmetric ellipse. One side bowed out more than the other, if you think about it. Okay, here's the handy dandy formula. All right. So if you're the observer, you're going to hear a certain frequency, and that's FO. O is going to be for the observer. All righty. And what it is, it's the velocity of sound. Sound minus, no, not minus, plus the velocity of the observer. divided by the velocity of sound, once again, plus the velocity of the source. Okay, so here we go. And all of that times so that fraction times the original frequency of the source, whatever that happens to be. Okay? So let's write some stuff down. So F of O is the frequency heard by observer. F of S is the frequency sent by the source, like the train. The velocity of the observer is what that is. If you're just standing there, then your velocity is 0 meters per second, right? And finally, Vs is the velocity of the source. Could be the velocity of the train, right? Okay. Let the velocity of sound equal 342 meters per second. We're going to assume that if nobody tells you anything. I know the velocity depends on temperature, but I don't care right now. Okay, let's just use 342 for us. Okay, okie dokie. Let's do an example unless we got any other quick questions. Okay, let's do let's do a crow. So here we go. A crow. So EX example. A crow going 2.50 meters per second is pursued by a sparrow. The sparrow is yelling at the crow to get out of the neighborhood. That's what sparrows do. Sparrow going 4.50 meters per second. And chirping, right? Chirp, 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 chirping at, let's make it a fairly high chirp, 522 hertz. And the question, of course, is what frequency does the crow hear? Here, I can't spell this one. Okay, everybody got that? So, and there's one more. There's Larissa. Okay, so here we go. My suggestion is you draw a picture, okay? So, I'll draw a picture down here. So what we got is the sparrow, that's a little bird. And the sparrow, its velocity was 4.5 meters per second, 4.50. And then we got a bigger bird, we got the crow. And that sucker's going 2.5 meters per second. Okay, which one is the observer and which one is the source? So can you tell me in words which one is which? Okay, sparrow, crow, sparrow, crow. Okay, which one's the observer, which one's the source? In the meantime, I'll look at a question here. Yes, that's correct. That's correct. Exactly, Magdalena. We're going to take that into account in just a moment. Okay, so type in, everybody. Wake up. Smell the coffee. The crow is what up here? What's its velocity? So it's v, but which v? It's not the velocity of sound. What's the crow's velocity? And what's the sparrow's velocity, okay? Observer is the crow. Thank you, Tom. So we're going to call that VO. So the velocity of the observer, that's 2.5 meters per second. And the velocity of the crow, so somebody else, the crow is the sparrow is what then? The crow's the observer, right? Thank you, Riley. What about the sparrow? What do we call the sparrow in physics language here in terms of waves? Sparrow is the, type it in, please. Because I got to make some boardroom. It's the source. Thank you, thank you, thank you. Chopra, Riley, Isabella, Tadashi. So let's put a little VFS, okay? Now, Magdalena's right. It matters their motion, and it kind of goes like this. Okay, notice the sparrow is heading towards the crow. Choo, 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 choo. So I'm going to draw little waves coming out, right? Choo, 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 choo. Okay. Well, the sparrow's moving towards the crow. That's going to increase the effect, won't it? So I'm going to leave that positive. However, and this is important, this is what Magdalena was asking about. However, the crow, this sucker's trying to fly away. Well, that would decrease the Doppler effect. So it's going to be a negative 2.5 meters per second, okay? Because it's flying away. That's important. So that requires some thinking on your part. Okay, let's go ahead and put the numbers in. We're going to let the speed of sound be, again, 342 meters per second. Okay, let's plug and chug. Got a calculator? Please get a calculator and do this with me. Okay, so f of 0 equals, so that's going to be f of the crow. That's what we want. The frequency heard by the crow. The velocity of sound, 342 meters per second, and that's on the bottom as well. 342 meters per second. And then I got to go plus. Dang it. These are not both plus. Why did I do that? Oh, pardon me. Okay, so that bottom one is minus. Okay, stop. Change your notes. Mr. White screwed up. The bottom one here is minus. I guess I'm not quite awake yet either. So before we do anything else, change that, please. Oh, it's hard to get good teachers, isn't it? Okay, so 345, so 342 meters per second plus the velocity observer. Oh, but the observer's velocity was a negative 2.5. So we've got to just put that in parentheses. You can do that, negative 2.50 meters per second. That's okay. And on the bottom, it really is 342 meters per second minus the velocity of the source. That was our sparrow. So that's 4.50 meters per second. All of that times, oh, the chirping. Where's the chirping? There it is, 522 hertz. Okay? 522 hertz. Okay? Punch it out. Let me know what you get. Round it to the right number of sig figs. So let's compare some answers. So the frequency heard by the crow is what? And if you don't have a calculator, you can, yeah, late is something else, Julian. I can give you half the points, but half an hour is damn late. Okay, so if you don't have a calculator, well, think about it a little bit. Okay, so is the sound heard by the crow going to be higher or lower than 522 hertz? Think of my picture, look at the relative velocities, and take a guess. And for everybody else who has a calculator, please punch it out and type in an answer once you round it and put a label on it. What's the frequency that the crow hears? Okay, and I got an answer from Lee. And let's see if others get the same thing. Lower? No, actually it's going to be higher. It should be higher, Marla. Because the crow's out in front, like it being out in front of the train. And the sparrow's gaining on the crow too, so it's definitely going to be higher. Okay, let's get another answer too and see if we agree with Lee. And go ahead and round it if you would, your answer, whatever that may be. Look at the sig figs I gave you. I don't want to wait here all day. Come on, get out your calculator, please. And thank you, Lee, for starting. Still waiting for a couple people to give me their answer. Let's check there with Lee C. Got the same, Shilpa. Thank you. Okay, let's round it. How many sig figs did I give you? All the numbers I gave you. How many significant figures? And Riley got the same, and Maryla, good. Thank you all for doing that. Okay, let's round it. So Lee gave us what? 525.1. We should probably round it to 3. Thank you, Shilpa. 525 hertz. Well, what was sent out? Okay, what was sent out by the sparrow was 522, so not surprisingly, it's slightly higher, isn't it? Why? Because the sparrow's gaining on the crow. So that's going to increase the effect. More compressions hitting the crow per second. Just a big, not a big difference, but enough so you would hear it, by the way. Yeah. So this would hear a higher chirping, and maybe then, who knows what would happen. But until they meet or whatever. Good. I'm going to assign you about 3 of these problems to do for the rest of the week. They shouldn't take you that long, okay? I'll send those to you in an assignment in Google Classroom to try out the Doppler equation. But it's pretty user-friendly, okay? Just think about it. Draw a picture, think about if it's positive or negative, the different velocities, okay? What if the source would be silent? I don't know what you mean. Then there wouldn't be any problem. No, there would not be a Doppler effect. If there's no wave coming out, there's no Doppler effect. By the way, the same effect happens with light and stars, stars that are moving towards Earth or away from Earth. We see a Doppler effect, a shift, as it's called, okay? You'll get that in another course, but we don't have time for that this year. Okay, my people, that's the new stuff. Now, I want to talk to you a bit about, because I've done these for, I don't know, 13 years. I want to talk to you about the MSA, because you got that coming up next week, right? I'm going to give you some advice and then take some questions. So bye-bye, Crow. Okay, so where's my 10th grade stuff? It's right back here. Hold on. I had 3 things I want to tell you. Okay, so MSA advice. It's pretty simple. I probably don't even need to look here. First thing is dress nice. I don't mean casual. I don't mean sexy. I mean just dress nice, like a business way. So no t-shirts. If you're going to wear jeans, make really nice jeans or just wear some other slacks or something, okay? All right. Second, eye contact. You probably know that already. And don't just read your note cards. I think the Doppler effect's really interesting because it can be used, but okay, don't do that. Practice a lot and do it in front of an adult audience. Do it in front of your parents, do it in front of your neighbors, okay? Do it in front of, okay, whoever, the person down the street. Because you want to get some feedback and maybe somebody who's honest with you. So practice, practice, practice. And ideally at least a couple times in front of adults. Isabella, that doesn't, okay. Isabella, good. She says that there's a color change of the stars. Actually, there is, Isabella. You and I are not scientists, so we can't measure it exactly, but they're shifted towards the red or blue a little bit, depending if the stars are moving towards us or away from us. So that is a way that scientists can figure out the relative velocity of stars compared to the Earth. It's cool. And back to a question from Lee. How to figure out if the velocity is positive or negative. Okay, if it's going towards the source, it's positive. If it's going away from the source, it's negative. That's pretty much it. Towards the source, positive, away from, negative. Because towards will increase the effect, going away will decrease the effect. Okay, back to the MSR. So dress nice, eye contact, don't just read note cards. Lots of contact. Oh yeah, I meant to actually say this earlier. Don't just do a PowerPoint. Please have something else to make it interesting for your audience, like me or whoever it may be, some teachers, okay? And you're going to have just 2 or 3 teachers in a big room. So figure out a demo, figure out a model, figure out some other tiny thing you can show or do, okay? So try not just to have a PowerPoint. Okay, there was one other thing. Okay, so dress nice, eye contact, practice a lot, have something besides your PowerPoint, and um, I don't know, smile, show some enthusiasm. There was one other point. I think I wrote it down. Let me see if I can recall it. Hold on a sec. No, that's pretty much it. That's pretty much it. So, I've done MSRs since the very beginning. So I've done it for 14 years and I've watched a lot of them. I've seen the good, the bad, the ugly. Most of them pretty okay. What advice do you have? Not what advice. What questions do you have about the MSA? Usually there's going to be your main teacher, one other teacher in the field, and a third teacher from another field. Others may show up, but it doesn't happen that often. So usually you'll have like 3 people that'll be watching you, grading you. Okay. What we grade is 2/3 of your grade is on the presentation, 1/3 is on the content. So it's really very much about presentation skills. Smile, even though it may be hard. Try and be as relaxed as you can. We'll have a little water for you. We'll try and make the room reasonable for you. You can go in and check the rooms out a couple days before, okay? So go in and check your room out, you and your partner, and see what it's like and see, you know, where everything is in that room and if you can get your PowerPoint going and what it will look like in that room, okay? Because that'll be your responsibility to set stuff up. Questions from you about the MSA? Oh, really? Well, that's news to me, Riley. I guess they don't tell the teachers everything. If you're really going to have the MSA on Google Meet, then you're not going to be able to do much else other than a PowerPoint. All right. Is that truly what's going on? Okay. So, can someone else verify what Riley said? Is that what they sent you in an email? That the MSAs are all on Google Meet because they have not told that to us teachers. We're the last to know, maybe. Okay, they're letting us know at the end of the week about who is there. Okay? Thank you, Lily, for telling me. That's fine. Any other MSI type questions? And Riley, okay, you say it isn't 100% decided yet. Okay, so let's wait and see what happens. Okay? Yeah, you double check. Good. Double check and let your class chat know, Riley. Like I said, usually they tell us. So let's wait and see. If it's a Google Meet, then you'll have to do it that way. But if not, if it's live, which I think it will be, um, because frankly, there's only a couple of us in a big room. It's not really a corona problem. We'll have the windows open. We'll have masks on. Pretty small problem. Yeah, you shouldn't. Yeah, you're allowed to have note cards, of course, but primarily reading from them is a bad idea. You know what I do, quite frankly, and I've done geology presentations years ago. Use your slides. Use your Google Meet slides. If you got to do it on Google Meet, use your PowerPoint. Just glance up at it, and then you know what's there, and you can talk to the audience. You don't really need to have it on cards. You got your Google. You got your slides. You got your PowerPoint presentation up on the screen. So you don't have to use that. Okay. So yes, you can use cards, but and if you've done it a bunch of times, you may not need the cards. You can have the cards sitting there in an emergency, really flustered, but you may know it so well you don't really need it. But use your presentation to cue you to what you want to say. That's up there for you anyway. Your PowerPoint up on the screen. Okay. Good questions. Anything else I can tell you about or suggest to you or decide if your suggestions are good ones? And I'm not seeing any other questions come in. Oh, there's one from Lee. Okay. Would it be better timed if it was slightly above or below 20 minutes for two people presenting? Um, you don't want it too much above or below, Lee. So just do it enough so you come in fairly close to 20. If you're a little over, it's okay. But I've had a couple where we had to cut them off. And so they didn't even get to their conclusion. And that was a drag because it cut down their grade. It's not a good presentation unless you can give your conclusion. And remember, your conclusion is going to be to answer your leitende Frage. Answer your question. At the end of it, you need to answer that. Like with me, we always answer the objective. And your MSA, you're going to answer that question really clearly at the end. And really, your whole presentation should be focused at that question. But at the end, answer it. Okay, so it's not on Google Meets. Okay, thank you, Riley. Okay, anything else? Magdalena. Okay, other than a PowerPoint, you could do like a, a question and answer back with your partner to introduce the topic. So 15, 20 seconds. It doesn't have to be long. You could do a poll of the audience. Okay. How many of you, blah, blah, blah. All right. You could do a video, but it's got to be really short, 20-second video or whatever. You can make a model. Okay. You could have a poster. That's what I would do, especially if I had like pros and cons. Show this in my poster as well. So it's not just a PowerPoint presentation. That's what we call the media choice. Okay. Because I'll be really honest, I've been through a lot of PowerPoints and they can get pretty boring. So if you have a little something else, it kind of shakes things up a little bit. Okay. You don't have to, but it's a suggestion. Okay. When would you recommend having everything done by? You guys give them like the 26th or whatever. I'd have them done at least 2-3 days before, so you got time to practice, practice, practice. Give yourself at least 2-3 days to do a bunch of practicing, and then you can tweak it, change it anyway if it's not working out so well. Don't wait till the last minute to do it in front of adults. Do it at least a day before so you can change something if they think it's not really all that great. Okay? So give yourself a little time. Give yourself 2-3 days to get it in its final form by doing it in front of some people. Noah's here. Okay, so Noah, just watch the video and take some notes and send me your notes. Will points be taken off someone if they can't answer a question teachers ask? It's not like points taken off. You just don't get the points, Lee. So if people don't answer the question well, then that portion of the MSI rating system, we don't rate you that high if you can't answer any of the questions. Just do your best to answer the questions, okay? We're not trying to intimidate you or kill you. Okay, I'm reading other comments. Okay, Nicholas is here. Although, Nicholas, if you're this late, you need to go and watch the video. Yeah, photographs by the 20th, send in by your slides. Thank you, Lily, so that may answer that. Okay, and our time's about over. If you get any other burning questions, you can always email me. Okay, so thank you very much for joining me. Good discussion, and I'll send you a couple problems. So we won't meet every day this week because I want to give you time to work on your MSRs as well, okay? So we might even not meet at all. I just want you to try a couple of Doppler problems, but it won't take you that long. So work on your MSAs, okay? Be healthy, be good. Bye-bye.